Hello, let's start with some important soil properties. Look, we all know that soil is a three-phase system. Soil consists of three phases, but basically soil is made up of two components. One component is simply solids, and these solids are placed or these solids are present at some particular distances or connected with each other, but it may not be possible that these solids are present as a continuous matter. So in general there is some mean free path available within the solids which we call as simply voids. So basically soil is composed of voids, and soil is composed of solids. Then these voids may contain air or water. Okay, so based upon the presence of these materials, we just define some properties to get an idea about the presence of these materials. First of all, we will cover water. So the presence of water in the soil can be explained by a factor called as water content. Okay, so the first factor that I will discuss is water content, or we call it as moisture content. So water content is simply termed as the presence of water in the soil. So presence of water we define in terms of solids. So we simply define weight of water upon weight of solids expressed as percentage. This is simply termed as water content. Okay, so we have covered water. Next, for this three-phase system, I will define these as volume of solids. These are volume of voids. In this we have air. This is water. This is called as volume of air, and this is volume of water. So for these things we have already covered water. Now we have got voids. So we will talk about voids. Now voids are simply open spaces. So these open spaces can be explained on basis of two parameters. Okay, one, that is this volume of voids can be explained as compared to the whole volume of soil, this V, or it can be explained as compared to the material. So basically this material means volume of solids and the remaining gaps means volume of voids. So when you compare volume of voids with respect to the material, then it is called as void ratio. However, whenever you compare the volume of voids or the total open spaces in the soil itself, that is total volume, then it is called as porosity, and porosity is expressed as 100%. So for voids you can consider solids and you can consider total soil. Okay, so whenever you compare the volume of voids with respect to solids, it is void ratio, and with respect to voids it is simply porosity. Third I must tell you that it is about these voids. Now voids contain air and voids contain water. So basically we will cover first air. So regarding air you define two parameters. Okay, so regarding air you define two parameters, and regarding water you define one parameter. So how much volume of water is present in the voids, this you can write, or you can write simply volume of voids. Okay, how much volume of air is there in the voids. So how much air is there in the voids and how much water is there in the voids, I have written this. This volume of water upon voids means how much water is there in the voids is termed as degree of saturation, while this is termed as air content. It is just simple. You can compare, or you can just remember in this manner that voids contain water and voids contain air. So the voids contain water, which is called as degree of saturation, and voids contain air, which is called as simply air content. Now air can be seen with respect to total volume of soil also. So simply if you consider volume of air with respect to total volume of soil, as in the case of porosity, you can define it as percentage air content. So this is called as percentage air content. This is called as air content. This is called as degree of saturation. This is called as porosity. This is called as voids ratio, and simply this is called as water content. Okay, so this was just basic. We all know about this one. Now afterwards you can just see about what we can write about these things. Now look at that. If you consider water content, then water content is simply weight of water upon weight of solids. So basically the weight of water can be as much as, you can write 10 gram or you can write 20 gram. It is independent of weight of solids, which may be again 1 kg or simply 100 gram or 1000 gram. So there may be arbitrary amount of solids, and behind that there may be any amount of water. So there is no upper limit for water content, because WW can go as much as more than WS also, because these are solids. So if these solids weigh 100 gram, then it is not necessary there cannot be a water content more, or weight of water more than 100. So weight of water may be more than 100. Therefore simply water content is WW upon WS multiplied by 100. So this can be 0 to infinity. So it is no upper limit for W. Similarly for voids ratio, it is simply volume of voids upon volume of solids. So void ratio is VV upon VS. So in this case also there may be amount of solids, there may be as much as voids as there can be. So basically these solids can be placed like this, or this solids can be placed like this. So in this case void ratio will be more, in this case void ratio will be less, with equal amount of solids. So for same amount of solids, here it is more voids, here it is less voids. So these volume of voids can be as much as possible. So therefore for E also you can write 0 to infinity, no upper limit for void ratio. However here it is volume of water, here it is volume of air. So you can see about porosity, it is simply volume of voids upon total volume of soil. So within the total volume of soil there lies volume of voids. So if VV increase, then V also increase. Thereby we can say that VV cannot be greater than V. Okay, so VV cannot be equal to V also. This case is also valid, and this is also valid, because entire solid would not consist of voids only. It would consider some amount of solids. It will consist some amount of solids. Thereby I can say that these are not possible. Also VV cannot be 0. So from these conclusions, if VV is not equal to V, not greater than V, then porosity must be, because it is 100%, it cannot be greater than 100%, because if VV is not greater than V, then it cannot be greater than 1. So it is 100%. Now you say that VV is not equal to V, therefore it is not equal to 100%. So it is only less than 100%, and VV is not equal to 0. Okay, so it is always greater than 0. So you can write here porosity. So this is the range for porosity. So basically porosity cannot be equal to 100%, cannot be equal to 0%, but it can lie within 0 and 100%. Okay, next is about degree of saturation and air content. We define degree of saturation as the water present in voids, while we define air content as the air present in voids. So this degree of saturation, simply it is also expressed in percentage. So in this case you can say that if volume of, I'm just writing confusions, volume of voids is full of water, so entire voids are filled with water, it is called as SR is equal to 1, or you can say it as fully saturated condition. This is fully saturated condition. However, if you say that VW is equal to 0, there is no water, or you can say VV is equal to VA. So in this case you can say that SR is 0 and soil is dry. You can just look at the VV is equal to VA, or you can say that VW is equal to 0. So this VW will be automatically 0, because you can write VV is equal to VA plus VW. So in this case VV plus is for this case you can write VV upon V is equal to VA upon VV and VW upon VV. So this get cancelled and this remains as VA upon VV is nothing but air content. This is nothing but degree of saturation is equal to 1. So remember this relation also. So from this you can say that volume of voids equal to volume of air means VW is 0, and in that case soil is dry. For these situations I can simply write that degree of saturation may be equal to 100%, it may be equal to 0%, and it may lie between 0 to 100%. Thereby I can write degree of saturation is greater or equal to 0 but less than or equal to 100%. There is an upper limit. The same conditions is valid for AC also. Air content can also be, because air content means only air replaces water. So basically both of these things are same for the air content. Okay, I will go back to void ratio again. This void ratio E you can define for 3 states. You define 3 states for this void ratio. I will just discuss about those 3 states. These 3 states consist of the state which is densest. So for that densest state the void ratio falls down, because if densest state is to be considered then there are less void spaces. So for this void ratio will be minimum. Next, if you decrease the densification of soil, or if you reduce the compaction, or just spread this soil mass, then the voids will continuously increase. In that case void ratio will be maximum. So I can say it as maximum, and in between there is some void ratio E. Okay, some void ratio E. So basically these limits are found out mathematically. So how they are found out, which is not important, you just remember these values. So minimum void ratio is 0.35 and it is 0.91. so theoretically these are found out by considering the lattice structure. So we will not go in that. So by considering lattice structure, theoretical maximum void ratio is 0.91 and theoretically minimum void ratio it is 0.35. So you just remember about these 2 things. Okay, further I must say, okay, we have done with this. Okay, next I will just explain density index. If we are already here around the maximum and minimum, so we just can explain density index that we have seen here. E, that is the field or regular void ratio, field void ratio. Okay, then we have seen the maximum void ratio, maximum. So this is to be in case of loosest state of soil. Similarly we have seen minimum void ratio. This is in case of densest state of soil. Now look, for whenever we consider densification of soil or amount, what is the density of soil, then the compactness of soil can be defined by a term called as density index. Most importantly, density index is a function of void ratio. Okay, is a function of void ratio, and simply it is seen that density index with respect to void ratio can vary linearly in this manner. So here if I plot void ratio and here if I plot the variation of density index, then denseness of the soil can be explained by this called as density index, or it is also called as relative density. Okay, so this function, this density index is a function of void ratio, and you can see that whenever the void ratio is maximum, density index is 0. I mean the density is very less, so density index will 0. When void ratio is minimum, density index is maximum. So maximum ratio of density index varies between 0 and 1 only. So basically, because these are facts, so we just defined this one. So this is the maximum void ratio, this is E max, and this is the minimum void ratio, this is E minimum. So any void ratio, for any void ratio E, you can find the value of, or you can find the amount of densification of soil. This is ID. Now maximum value of ID is 1. So by similar triangles, you can simply write about this one. If you are writing this one, so you can simply write ID minus 0, ID minus 0 divided by E max minus E minimum is equal to 1 minus 0 divided by E max minus E minimum. Sorry, here it is E minimum. ID minus 0 divided by E max minus E, and afterwards I have written this 1 minus 0 divided by E max minus E minimum. So for similar triangles, I can just ID is equal to E max minus E upon E max minus E minimum. So we get this formula, and we just express density index in terms of percentage. So I multiply here 100%. Now we have got some range and classification of soil based upon density index. So this classification is simply like this. This is 0%, 100%. So you can simply write that 0%. Afterwards you can leave alone 15% from this and 15% from this side, 85, and then in center you can go ahead 20% more, so 35%, it is 65%. This state is called as very loose. This is called as loosest, or sorry, this is called as loose only. This is called as very dense, and this is called as dense, and this is called as medium. Okay, so this is simply what we do. So that's it for this. Next time we will see next properties.